All right. Yes, indeed. That dramatic music means only one thing, and it's time to talk security. In another episode of DevSecOps is the Way, welcome to all my internet friends across the globe watching this either through Twitch or YouTube. This is episode 8 of DevSecOps is the Way. My name is Dave Muir. I'm a global principal solutions architect here at Red Hat. I'm focused on our security ISVs. Typically those folks who work with us on top of OpenShift and Ansible. And we have a fantastic show for you today. This month is monitoring month, and we have a very special guest from Sysdig. Sysdig is one of Red Hat's great partners. But before I let Alex introduce himself, I just wanted to remind the audience that DevSecOps is the Way is part of a monthly series. You can see that we've been doing this since March. And we've had different categories every month. We're actually in the planning stages of what we should do next year in terms of each month. But for the series, for the monthly series, we put out podcasts, Red Hat live streaming shows like this one, blogs. For any information, you can always look at red.ht/DevSecOps. All righty. So with that, I am going to bring in Alex. Hello, Alex.
Hey, how's it going? Thanks for having me today.
You bet. Let me get us on equal video ground here. So if you could go ahead and introduce yourself to our audience.
Yeah, I'm Alexander Lawrence. I work over here at Sysdig. I'm a principal solutions engineer for them, kind of working on all sorts of nerdy things across the West Coast.
Yeah, so we're actually coming to you from opposite ends of the continent. I'm on the eastern side of the United States in Tampa Bay. Alex is in somewhat sunny Seattle, right?
It's partly cloudy Seattle today, yeah, but not too bad.
Well, good. One thing when we were talking earlier was interesting is we have to bring up your past efforts and experience in bioluminescence and fungus. Can you give our audience a second what that is?
Yeah, my degree's in biology and pursued a master's in mycology and predominantly studied bioluminescence and the kind of coevolution therein of aquatic and terrestrial organisms. About bioluminescence in general and kind of how interrelated. Nobody really cares about that though. And so I ended up going into technology instead.
Yeah, I don't care too much about fungus either. I'm not a big mushroom fan on my pizzas, but that's all I know about fungus.
I fully attest to people who don't like mushrooms have never had them the right way. So you can get there someday. Understood.
Well, cool. So today we're talking about monitoring and we're going to dive into forensics, which is, I think, a key feature of Sysdig. We're going to spend about the next 40 or so minutes talking about that, going into a demo. I guess before we get there, Alex, wanted to mention a couple things. Your recent past, you have done some work with open source software. Is that right?
Yeah, a fair amount. A lot of my career was in the EDU and K-12 space prior to coming over to this part of the IT world, and did a lot of work with identity management when I was at Pacific Lutheran University around a few different projects, predominantly Shibboleth and CADS. So trying to deal with identity, who you are, authority and access management, kind of that whole stack of things. And PLU ended up building a really intriguing system based on those by integrating their ERP banner as kind of the source of identity into their various directories, right? They ran multiple different ones. They had to use a special schema called EDU person that most universities use. And so then it was a matter of figuring out how do you handle entitlements in kind of that world of things and have data flow from student prospect to actual student to member at the university and who has access to what. And so it was leveraging tools like Shibboleth to handle entitlements about who an individual was in particular, what they had access to, and then building policy and management around that for what they could do or what type of passwords they could have. So integrating tools like ZXCVBN and doing password entropy calculations. And the goal there was to enable users and enable students and faculty to have strong passwords and do it in a way that wasn't cumbersome. And so the university and the team decided the best way to do that was to do entropy based passwords and kind of have a level set of who you are to dictate how long you can keep a password, what can be used against, things like that. And so it was a really novel way to implement kind of that whole open source stack on identity. I think these days they've even gotten to the point where they've integrated two-factor authentication with Duo and things like that into the solution set. It's being ran by David Allen and Darren Struthers over at PLU these days. Really, really cool solution. I've been telling them they should open source the whole kit because it's a really novel way to do passwords. And I think it's fantastic, right? Supported spaces and passwords, any character in passwords. It was very, very flexible.
Sounds awesome. Yeah, passwords are the bane of my existence. I always say we have an identity problem every single day when I'm trying to use passwords. It sounds like though that entropy capability allowed you to sort of like compare yourself against other students, right, or departments.
Yeah, that was one of the design goals with the project, was to capture metadata about who the individual was when they were generating passwords, so that as you create a password and you create one with better entropy, you'd be able to kind of get a quick view of what other people had been doing. So the example I always use was if you're a computer science professor and you have to make your new password, wouldn't it be great if we could start displaying, the entropy level on average that your students have that you're teaching, or the entropy level of other faculty in the university, like in the humanities department, or the library employees, right? Like, how did you compare to other groups on campus? And, maybe you should feel bad that your entropy is, a factor of 10 worse than these other people, these other groups, and maybe you should do better, right? Yeah. We weren't telling people that they had to have these ridiculously complex passwords. We were just encouraging them to have better entropy based off of kind of who they were and what they were. And the whole goal there was, we shouldn't dictate to people that they have to have so many characters and so many exclamation points or special characters, caps, numbers, all that jazz. If your entropy's high and it's good, why can't that qualify? And so, I was notorious for using movie quotes as passwords because they were easy to remember. I could type them out well, right? Had spaces and other things in them. It made them complex. And it was an easy way to do passwords for me personally. And that was kind of the whole goal, was let's enable our users to do this well without being bogged down by, random character generation and things like that.
Right. Yeah. Nice. Very cool. Well, from one set of open source projects to the other, Sysdig actually does a lot in the open source world as well. You want to chat about those couple projects?
Yeah. So Sysdig's kind of whole stance on this world is in the cloud native world, in this DevSecOps world. A lot of the projects we're all using in production to build our applications are derived from open source. Whether or not they are an implementation of an open source project, or they are open source themselves, they are these large projects like Kubernetes that are being very heavily contributed to across the globe by thousands and thousands of contributors. When you start building IP to help do things against that stack, and you're doing it in a closed model, it's really hard to keep up, right? So if you're trying to have a closed source solution, do everything security for Kubernetes, that's a difficult model because you're basically saying that my 300, my 500 developers are better and faster at producing applications and producing code than the entire rest of the globe supporting this one particular project, right? And so because of that belief, a lot of what we do here at Sysdig is derived in the open source space. So like our runtime engine is Falco. It's a CNCF project that we donated to them. Originally it was Sysdig. We ended up writing a lot of the stuff around it, but we felt like there was something about this project that was bigger than ourselves, and wanted to leverage the community to see it grow and foster it and build something bigger and better. Do the same thing for a lot of the other tooling in the product itself as well, right? It's all about kind of wrapping best of breed open source solutions so that we can help our user base keep up with the ever evolving world of containers and Kubernetes and kind of cloud native development.
Right. Yeah. So well said. I was at KubeCon actually last week, and you just get that same feeling that the community is so vibrant and rich, and there's a lot of people from different companies just contributing to making these projects better, right? So yeah, and trying to do that in closed source with a small team doesn't even obviously scale or compete to something like a global community.
Exactly.
Cool. Well, let's dive into what we're planning to talk about today, which is monitoring and how Sysdig does monitoring and forensics. Where would you like to start?
Yeah. So I think the best place to start is to kind of just level set a little bit about the way Sysdig works, kind of the way our core of the product functions and gathers data. And from there, I'm just going to jump right into demos and showing stuff off, right? We don't really want to bore people with slideware or kind of walk through value prop. Let's just get into the nuts and bolts of the nerdy things and have a little bit of fun.
Sounds great.
So I'm going to go ahead and share a window.
All righty.
Cool. So this here is admittedly a picture of a slide, so I do apologize for that. But it illustrates the way Sysdig approaches instrumentation in the world. And so we have a couple different things. We already talked about Falco, and we talked a little bit about Sysdig. There's also an open source variant of Sysdig that is the same name, Sysdig. And the end of the day, they do a very similar instrumentation model. And what that is to inject a kernel module or an eBPF application into the host kernel, right? When you start talking containers and Kubernetes and a distributed world, you don't have things like a switch or a span port or the ability to capture, packets across the infrastructure in a way like Wireshark used to. And so how do you build tools that have ultimate observability and from both a monitoring perspective and a security perspective when you can't grab packets, you can't instrument the infrastructure, the switching, the things like that. And Sysdig's approach is, okay, well, let's go to the least common denominator. Let's go to the host kernel, right? So if we instrument the kernel, we can then see all of the things coming out of the containers that are running above that kernel. We can see all of the processes, all of the applications, everything that's going on has to make a call to that kernel to get access to resource. And if we can capture those system calls, we can get all sorts of crazy visibility across that entire stack from both a security perspective and an observability perspective. And so what that looks like in the actual product itself is it gives you, metrics and data across everything, be that from individual processes or containers or pods. We've done the same thing by instrumenting the Kubernetes audit API and CloudTrail and things like that across the infrastructure. So I think if you were paying attention to Sysdig at KubeCon and Falco at KubeCon, you saw some announcements come out about being able to now instrument different logging sources into Falco. And that's something that Sysdig has been doing for a while now in the enterprise product and has made its way into the open source offering as well. Yeah, so basically what that means, oh, sorry.
I was just saying, yeah, that's nice.
Yeah. The cool thing about that, what that really means for the user base is that you're not just stuck with system calls anymore against the Falco runtime. You can now ingest logging data as well to be able to react to events that come through that. And so in our world, that's really like ingesting the Kubernetes audit API and taking actionable events from that and be able to do something with it. Or from the CloudTrail logging from AWS or one of the other major clouds and being able to react to events happening across your infrastructure. So it's really about ingesting more data and using the same runtime engine to be able to do cool and novel things with that. So in the monitoring world, this is really about looking at metrics, right? Looking at processes, looking at stuff going on across your clusters. And right now, this is kind of just a high-level overview of various ones in our lab. I can highlight a particular cluster and I can get into all sorts of events coming from it. So in this case, you can see we got a lot of backoffs happening. It's the demo environment. It's not unexpected. If you saw something like this in your production environment, this should be indicative of a problem, right? Yeah. And so maybe you want to investigate that further. And so ways you can do that is to come in and look at things like, my node's up and running. Do I have all the pods I would expect? How do my resources look across that cluster? Maybe I should dive into the namespaces, look at my applications running in the particular cluster, look for areas where we might have issues. So like this Java application, we can see that it is showing a significant overcommit on memory. So if I highlight that, I can see what's going on in here event-wise. We see a number of containers dying off, containers unhealthy. And so really this interface is about aggregating data up to a central place to give you quick overviews and quick views of what's going on inside that infrastructure. This is ever evolving in Sysdig. You'll see this overview page changing here in the future with other information and more data as well to help people troubleshoot and see what's going on. But the general concept here is just highlighting workloads, highlighting services, and trying to give you deep information into what's going on across that stack and where you might be having issues. Like in this case, we can see a Cassandra workload inside that Java application. is having a service degradation problem, right? And it likely is because we're very much exceeding memory utilization, right?
Yeah.
So with that, like, we can take these metrics and view them in different ways. So if I wanted to, I could come into a different view, like this pod right sizing view. I can say, well, I know I'm running into memory problems. Why is that? What's going on? And I can start looking through utilization across time. If I want, I can pop this out to like 2 weeks, and I can start seeing all sorts of data. And especially since we know this is a Java application, we're seeing something that is pretty darn descriptive, right? This seesaw of memory utilization and dropping back down is basically telling us that the JVM in question here keeps on using up to its limit. Garbage collection happens and it does it again. And so when we start seeing that seesaw, that memory requester from the containers, we know we've got something wrong, right? Maybe this is a memory limit problem. Maybe this is a memory leak issue inside of one of the Java applications. There's something going on here we should investigate further, right? And we can easily start seeing these things by looking at our data and trending it over time. I think you might have a question for me.
Yeah, thinking about CPU and memory, first thing that comes to mind in my head is crypto mining. So would somebody be able to say, oh, I can easily tell that this is some crypto mining activity or some type of threat that's related to this activity?
Yeah, that's a good question. And so you could do that a couple different ways in the solution. If you're focused on monitoring and observability, the way I like to demonstrate that is to come into my cluster. I can come into something like that same Java application, and I can go pull up a bunch of different views here. And the one for this one in particular that I like is really about processes. And so if I just start typing top processes, we can pull up a dashboard about that, and it'll actually list out every single process running inside of this given namespace, right? Yeah. So am I seeing things I shouldn't see, right? What's the Java exec that's going on? Does that look okay? Yeah, that's a Cassandra call. I'm seeing things like cut or Nginx running. I'm not really seeing anything that might point out to me that I've got a rogue process in here that I should really care about. And this is looking over the last 2 weeks, right? Yeah. Conversely, if I wanted to know more about some of that stuff in particular, in the secure product, there are some really cool ways to do process interrogation. So if I come over to my policies in secure, and I go look at my rules library, we've got a couple things out of the box for that. So if I start typing crypto, you can see here that it's detecting crypto miners using a particular protocol. And so what it's doing is inspecting the syscalls that are being executed on the particular container or node. And we're looking for a spawned process. And so basically saying if this process opens up and we see that the command line contains this little string right here, right? So if we detect that, we know this one in particular is a miner call, and we should then alert on that condition. And this is really just getting down to the way Falco does runtime detection. You can do all sorts of crazy things here and be able to do all sorts of different configurations with that. So like if I wanted to go look for, say, rogue network tools, I can start typing in something like network, and I can look for, let's see here, which one do I want? I want suspicious network tool in container. And so this runtime rule is really looking for various spawn processes, and they are of a particular list, right? So I'm looking for anything that matches this macro of network tool procs. So any proc name that is things like NC, NCAP, DIG, TCP dump, tshark, telnet. If any of these processes spawn in a container, I want to know about that, and then I can alert on that condition in real time.
Cool. Yeah, I should have mentioned, if anyone watching here wants to ask a question, feel free to ask questions. I'm getting all the chat here, so I can ask a question for Alex, or if you have a question for me, I don't know why you would, but feel free to send a question. We did have a comment, Alex. Stu really likes your dog. It's very cute.
Yeah, you can see him kind of walking around in the background there. That's Pippin. He's my office buddy, and nice. He normally hangs out with me throughout the day.
That's awesome. So I have a question. You showed us a couple items here. If you think about forensics and when security events happen, you probably showed us this already, but what are the most popular steps or screens or things that an operator would do with Sysdig to find out what happened and what action to take?
Yeah, it's a really good question. And the way we try to help people visualize this is in this thing that we call insights. And what it's doing is looking for events across your clusters. In this case, you can see we've got a few different ones running out there, some in EKS, AKS, AWS, GKE, all the different flavors. And we're surfacing up all of the details of stuff happening in each one of those clusters. What I like about this view is we aggregate things together so that you're not getting a bunch of logging data, pushing stuff that you might care about out of your purview, right? So this is the summary. We can see we're looping things together like writes below roots, deleting bash history. So a number of these events all kind of put together. If I go to my event view and start scrolling, you can see that those are fairly prevalent and start pushing other things out. And so maybe we don't want to see it in that particular way. We want to be able to visualize it in a way that lets us kind of surf through things, zoom in on what's going on, and kind of look deeper at particular things. So what I like to show here is that, we've got one occurrence of launching a suspicious network tool in a container. Maybe what someone's going to do is come in and, start writing below root a ton, create a bunch of noise. And while that script is going, they can go and start doing things you actually want to care about, right? A view like this lets you pick up on those things and then be able to investigate them further. So if I highlight, this one in particular, I can see that they had the launch suspicious network tool and container. I can go click on it and I can get details about, where it happened or what went on. I can take it over to the events view and then I can get metadata about it. So what types of compliance frameworks would you need to care about if this thing were to launch? Another way to put that is, if someone were to launch a suspicious network tool in a container, what compliance specs would care about that? So if you're trying to run a FedRAMP environment or you're trying to run a SOC 2 compliant environment, this is a type of rule that you're going to want to investigate further to make sure that you're not having an issue that relates to that compliancy you're trying to upkeep. Yeah. Conversely, we give you all of the data as well that goes along with it. So in this case, we can see it was the nmap process that was ran. From a particular container that was on this host's MAC address here inside of this scope of Kubernetes metadata. Now, if I wanted to take it a step further, I can do other investigation type stuff as well. So like, let's say we have an event that comes out where somebody launches a terminal, right? So if we just start typing terminal, we'll auto filter to any place that this terminal rule pops up. So we can see there's a terminal shell and container. If I go ahead and click that, I can then filter on all those particular events. If I highlight the terminal shell and container event, we'll see what we saw before, where we get that same listing of compliances as well as kind of the scope of where the event happened. But under my respond offering, I have this really interesting view called activity audit. And so one of the advantages that Sysdig is capturing system calls allows us to start building a history of things that happened across shells or other things in your environment for investigation later. So what I mean by that is, if I keep kind of going backwards here in time and kind of keep loading more data, we will eventually get to the kind of inception point here of the event itself. And what we'll see is, there it is. So we'll see a kube exec, right? So somebody came into this environment, did a kube exec against this particular namespace, this particular pod, and they evoked bash. So we see that bash opened up inside of the directory var www.html. They did an ls. They curled a file down from GitHub, removed a particular directory. They untarred the file they grabbed, and that evoked gzip. And then we had a bunch of files extracted to the file system. And they ended with the classic shredding of the history. So what I point out here is that it doesn't really matter it was a container that's no longer there. It doesn't really matter they tried to shred the history of the file inside the container itself. We have a running record of all the system calls that were ran, and we can go through and interrogate those and see what's up. So if I wanted to go in here, I can go grab the entire command line for the curl that did, and I can go inspect that file in a protected place. Or I could go look at the gzip command, and I can see that they ran tar xcvf, right? Inside of var www.html was ran by uid33, PID, parent PIDs. I could filter by all the parent commands, and I can see all the other stuff that they ran to make sure I didn't miss anything. Basically, it gives me a very nice forensics trail to go through and investigate after an event occurs in my environment.
Very nice. Cool. Yeah, there's actually a question that came up from Edvin. He's asking, is all of these built-in rules available in Falco out of the box?
Not all of them. Some of these are core to the Sysdig enterprise solution, but a number of these are also available in Falco. And so if I go into the rules library, you can see published by here. And so a lot of these are published by Sysdig in our current rule set. But a number of these also exist for Falco itself, like terminal shell and container. That's a rule that exists in Falco.
Yeah.
There's also the Cloud Native Security Hub. And you'll find on there that there's a number of rules that the community have written around detections for Falco. And then you can import these into your environment and execute them against your different things you're looking for.
Very cool. So obviously, you can create custom rules, correct?
Yes, yeah, you can customize to your heart's content.
Yeah. The forensics piece, how much of that is open source? How much of that is Sysdig Enterprise?
Yeah. So the workflow that I showed you is very much Sysdig, but there's nothing stopping you from trying to take the data streams that we put out there and then use something like Falco Sidekick. In order to push data out and be able to then capture it in different ways for kind of different auditing workflows as well. Really what we do here at Sysdig is try to give you a best of breed experience as you're trying to do security and observability across your stack. And if you want to build it yourself, totally fine. And if you want to start with something like Sysdig and kind of get used to the world and then take what you learned and be able to grab some of your policies you've built and port those out to open source stuff later, totally fine, right? Or do the reverse, where you started in the open source world, you had Falco, you really liked it, but you wanted some more built-in workflows, you didn't want to code it all yourself, you didn't want to build kind of the responses in yourself. That's where we can step in and help enhance those things.
Awesome. Okay. Well, thanks for the question, Edmund. Anybody else? Feel free to submit a question. What else do you have for us, Alex?
Yeah.
Obviously, that was a ton. It was great stuff. But yeah, anything else you wanted to share?
Yeah, I mean, we can go into all sorts of different stuff, right? The solution here really is about kind of the whole life cycle of application. We've talked a lot about kind of the runtime world, the runtime security aspect of things, which is definitely a strength of Sysdig and Falco. But there's other areas that are kind of interesting too. Like one thing I like to point out to a lot of our customers is that we've implemented a fairly unique way of doing network security policy inside your cluster, and it's because of our data source being at the system call level. Effectively, what we can do is come into a cluster. So we're looking at an AKS cluster. This is, again, our little friendly Java application. And we can build topology maps of the way traffic is flowing through your application. One of the areas customers come to us a lot is around compliance needs. And this particular view here helps significantly with that. Normally, one of kind of the table stake things you have to do when you're going through an audit or going through kind of different compliance frameworks is build a map of how the application communicates. And since we're at that system call level, we can do that for you. And so basically what you see here is a namespace called Java application. We've got a number of services inside that application, and we can then spec out, the labels on a particular deployments, the port that we're communicating on traffic-wise, the way traffic is flowing through the application. And then we can build security rules around how that traffic should flow. So in this case, the default is that everything inside the namespace is okay. Everything external to the namespace is not okay. That's why you can see these red lines versus these black lines. So I could take this, I could download the PDF, have this as an artifact for my auditing process. And I could even come in and say, well, I want to make this a little bit different. I want to tweak this so that we can't communicate with Mongo. I can go to my egress, I can come find the Mongo tag, and I can go ahead and just untick it. And then if I come back to my topology view, we'll see that line then goes red. So we're going to disable that communication there. This is what I want. So I'm going to go ahead and generate that topology, and then I'm going to generate a policy to go along with it. And I can apply this to my cluster to then dictate how that network policy is implemented, right? So basically saying that this is what the communication should look like. I don't want it to look like anything else, and we'll ensure that with this particular policy.
Sweet. And this data is all sourced from the Sysdig agent. Is that correct?
Correct. Yeah, the Sysdig agent runs across the nodes in your cluster, and we investigate all the system calls that are coming through that in particular node. And then we can generate these views based off those calls, right? Because we can see everything down to the headers of those packets and then be able to reconstruct the way something's flowing.
And I'm assuming that's like a daemon set, right? Installed.
Yes. Yeah, you install the agent as a daemon set in Kubernetes. If you don't like daemon sets for whatever reason, you could do it yourself, with a Helm chart. You could do it just by deploying containers. You could even deploy it as a raw process.
Cool. Yeah, and of course, for those who have multiple clusters in the cloud, on-prem, you just install the Sysdig agents in those clusters, and then they would report back to the console, correct?
Correct. Yeah.
Yeah.
So that's kind of one of the big things we like to do here is that we can show you all of your data across all of your clouds and all of your clusters. And so here you can see that we've got stuff in our demo environment and a couple different AWS accounts. We got some in GKE, and I can take that and build it into this composite view where I can start looking across all of my cloud environments, all of my clusters, all of my regions inside of those cloud accounts, and get an idea of where stuff's running.
Yeah.
If I do it from the monitor perspective, it's a little bit easier to see as well, where I can come up here and I can go to a view that's based on deployments and pods. And effectively what this does is it changes the view with the metadata that we pull in and lets you see it by cluster, right? So it could be on-prem stuff, it could be cloud things, it could be OpenShift, it could be ARO, right? It could be any number of different ways to implement, and you can see all that in one aggregated interface.
Cool. Yeah, and we didn't chat about this when we prepped for the show, but you may know this. If folks have multiple clusters, hundreds of clusters, they can use Red Hat, one of Red Hat's products called Advanced Cluster Management. Mm-hmm. And Sysdig was one of the first companies to contribute a policy to the governance part of that product. And what that means basically is you can automate the installation of the Sysdig agent across all of your clusters.
Yes,
it's pretty nice. Yeah. So
yeah, no, it's very it's one of the things that OpenShift does very well, right? Like there's a lot of different tools that will let you aggregate clusters into a single interface, but there's not many tools that let you be able to do kind of federated commands across everything to keep stuff in a particular state that you're looking for.
Cool. Awesome. Yeah, another question came in from another Alexander. So is upstream Falco different than the one bundled with IBM Cloud Pak for multi-cloud management?
That's a good question. And upstream Falco and the multi-cloud manager for IBM are it's effectively the Sysdig secure runtime. And that is the same as kind of the upstream Falco runtime. And so there isn't much difference there. Like most things that are kind of leveraging an open source project, it's likely that the Falco Rev is going to be a little bit ahead of what is shown up in MCM or in the Sysdig solution, just because the very nature of how the OSS development works, and then how it comes into the other products that are leveraging those OSS projects. But generally speaking, it's very, very similar.
Yeah. Man, I want to say multi-cloud management. Didn't that turn into ACM?
I'm not sure if the vernacular changed. I knew it as MCM, so at least I knew what they were referencing. But it might have changed names over to ACM. I can't keep up with all the acronyms.
Me too. Yeah, one of the cloud packs actually turned into Red Hat's Advanced Cluster Management, and I think it was the multi-cloud management. So that's exactly what we just talked about, where Falco and Sysdig have policies to install those agents. Cool. I had another question for you. It just dropped. Let's see. I can't think of it. So, yeah. Now I can think of it because you just showed this view. The one thing I like about this demo is there's a lot of vulnerable clusters. That's because there's no OpenShift here, right? It's all like AWS.
Absolutely right. It's all because it's not OpenShift. It's why it's vulnerable.
That's exactly right. Yeah.
Yeah, no, it's a demo environment, right? So we do all the bad things there, stuff you shouldn't be doing in production, things you should be able to react to, right? Like we've got policies here in Sysdig that kind of link rules together, and so if I come to runtime policy, you'll see something like oh gosh, where is it? Here it is, the NIST policy. So this is a policy built around the NIST framework for 800.190. So how you should do kind of application container security. And so you can see it's looking for stuff like launching disallowed containers, opening up SSH connections you shouldn't, rights below roots, opening up shells, kind of all that type of stuff. And one of the fun things you can do with the tool is that we can interact with the API that surrounds us. And so we can actually issue things like kill, stop, or pauses when these policies trigger. So if you're in production and somebody tries to say launch a privileged container and they shouldn't, right? You shouldn't be running your policy in that cluster is to not run containers with root privilege. You can actually go in and you can kill off the container or stop it. And these interact directly with the runtime API beneath it. So that could be Docker or it could be Cryo, whatever that is. Or the other fun one is pause. This one would do a C group freeze to the container processes. So I always tell folks to be super careful about a pause action because the the Kubernetes engine will not self-heal from a pause, but it will self-heal from a stop or a kill.
Yeah.
It doesn't really realize the application's gone down when it pauses with the cgroup freeze. So it's one of those things that it kind of looks like it should be the most innocuous one, but in fact, it's actually probably one of the more destructive things you can do.
Cool. Yeah, you're bleeding into next month's topic.
Sorry, I'll stop.
No, which is great. It's good stuff. Yeah, because we're going to be talking about what do you do, to remediate things, remediation tools, things like that. So good to know. But cool. What else? We've got about less than 10 minutes left. What else did you want to show us?
Yeah, I mean, there's all sorts of stuff I could talk about. I could talk your ear off about these things. I wanted to try to keep it into kind of the more monitory, metric-y side of stuff to a certain degree. I mean, there's other things in here too around, scanning, and you can see here that we've got events around rejecting stuff with our admission controller. So there's all sorts of stuff to integrate in Sysdig around the entire life cycle of your applications, and do it in all sorts of different ways. Like we've got customers who leverage us in their CI/CD pipeline before applications ever hit the repo. We've got other ones that look into the repositories specifically. I've got one customer whose entire use case exists around their customers who give them containers. And so they can't control the CI/CD pipeline, but then how do they protect their environment from what might contain malicious code? And so they use our admission controller to do all of the admission or rejection of those customer applications into their particular cluster. So all sorts of different ways to kind of handle what you were just talking about, incident response, remediation workflows, all sorts of fun things you can kind of handle across that lifecycle with Sysdig.
Very cool. Yeah, one question that actually popped in my mind was you were talking about compliance frameworks. I'm sure I saw it, but you do handle CIS benchmarks for Kubernetes, right?
Yeah. So that actually is in this posture tab. And if we come down to our benchmark tasks, you can see a bunch of different benchmarks here. And what it is taking things like the CIS benchmarks for Kubernetes or for Docker, for OpenShift, or for the GKE engine, kind of all the stuff there in between, even the Linux benchmark itself, and just make sure that your nodes are hardened and following those best practices.
Yep.
So if I highlighted like the Linux node check, you'd see stuff around that.
Cool. Yeah, I noticed you did have the CIS Red Hat OpenShift benchmarks as well, which our teams worked with the CIS team to create a specific version for OpenShift. And we worked with Sysdig as well to collaborate on that document.
What I like about these is that it gives you, again, artifacts to give to your auditor, right? So if I'm looking here at this CIS benchmark for Docker, basically it'll go through and say, here's the things you're doing right, and here's the things that you're not doing as per that check. So if you're not doing it, what is the check about? How are we addressing it? And what's the remediation procedure? And once you've gone through and remediated everything you want, you can actually download these as an artifact for your audit process. We all know that the most arduous portion of auditing is the documentation piece. And so we're doing what we can to help take that off of our customer base.
Yeah, sure is. Cool. All right. Anything else?
That's all I got.
Okay.
If you have anything else you want to ask, go for it. If the audience does, go for it. Otherwise, we can kind of just go about our nice, partly cloudy days.
That's right. Yeah. Well, let me give the audience time to ask any questions. And while they think about that, I'm going to share this last one thing here, which everybody has probably already seen from the beginning, but just a reminder that this series is a monthly series. We do streaming shows every month. So look on the calendar for DevSecOps is the way. Next month, as we mentioned, is remediation. If you missed any of the months, don't worry. All of the content is out on your fingertips. If you go to the Red Hat OpenShift YouTube channel, you'll see all of our DevSecOps is the way streaming shows. Go to Red Hat, catalog.redhat.com podcast. You'll find a bunch of our security podcasts. And then just some reference links. If you want to try Sysdig, go to sysdig.com and hit the free trial, or red.ht DevSecOps to learn more about what we do out here at Red Hat with DevSecOps, our point of view, and all the partners that we work with to provide, an enterprise comprehensive DevSecOps technical platform. And with that, I don't see any more questions, so we'll let everybody have a great day. I want to thank Alex for joining us from Sysdig. Appreciate it. Any final words to the
No,
audience?
just thanks for having me. It was great to be here. And if anybody wants to hit us up, you can always reach me at alex@sysdig.com.
Awesome. Well, thanks, Alex, and thanks everybody for watching. You all have a great day.
All right. Thank you.